Okay. Now let's move on to question 3, which focuses on why the median evidence or impact score is a strong indicator for triage in a large complaint system and how we can compute an approximate median effectively for massive data sets. In real-world complaint database, the volume of data can be extremely large, sometimes streaming continuously from multiple sources. So computing an exact median by sorting and using selection algorithms becomes computationally expensive. That is what we need: approximate but efficient techniques that provide medium or near medium value with control error. So let's discuss the three main approaches in large scale system. So here's the solution for it. Okay. So first is GK quantile summarizes, which stands for Greenwald Khanna. The first method is GK summary, a deterministic streaming algorithm. It stores a compact summary structure of the incoming data so that any value is its estimated rank differs from the true rank by no more than a smaller amount, epsilon times n. So its advantages are strong, mathematically guaranteed accuracy, ideal when exact errors are limited, and disadvantages are implementation is more complex, slightly more theory, more memory heavy compared to simpler methods. This method is chosen when strict accuracy is important. Second method is teeth digest. The second method is widely used in industry, including distributed systems like Elasticsearch. How it works: it clusters data points into weighted groups called centroids. These centroids are denser near critical percentiles, including the tails, but work equally well for the median. So the advantages for it are extremely accurate, works well for non-uniform distributions, can be merged across machines, making it a perfect large-scale or cloud environment. Some of the disadvantages of this method are: accuracy depends on compression parameters, more complex than simple sampling. T-digest is ideal when both accuracy and scalability are important. The next method is reservoir sampling. It's one of the simplest streaming algorithm. In the way it works is you maintain a fixed size reservoir of randomly selected elements from the stream. As new items arrive, some of these replace existing elements with a decreasing probability. So its advantages are extremely simple and fast, uses very little memory, efficient for real-time systems. Some of the disadvantages of this methods are: accuracy depends entirely on reservoir size. Results are probabilistic rather than guaranteed. This method is preferred when the speed and low memory consumption matter more than precision. Uh, Discussing the time and complexity of these methods. Reservoir occupies O of k, update time is O of 1. GK summary occupies O of 1 by epsilon log epsilon n times. Update time is O of log 1 by epsilon. T-digest is use O of delta, where delta is compression. Update time is O of 1 amortized. So discussing some practical heuristic, choosing the right method. Okay, depending on your system constraints, the best method changes. If memory is extremely limited and speed is critical, use reservoir sampling. If high accuracy is required in a distributed environment, use T-digest when supports merging summaries from multiple models. If you need strict error guarantees for analytics or compliance, use the GK summary. So that's it for this video. Hope you got this question. We'll discuss the question 4 in next video. Have a great day.